In the race to build artificial intelligence, it's easy to assume everyone is chasing the same destination with the same map: faster chips, bigger clusters, more raw power. From the outside, the industry looks unified, a single push toward smarter machines. But beneath that surface is a profound split in philosophy, one that goes far beyond hardware design. On one side, intelligence is spread across thousands of machines, stitched together through vast networks. On the other, intelligence is concentrated into a single, massive brain. This is not just a rivalry between companies. It's a disagreement about the very nature of thinking machines. This is the story of Cerebras versus NVIDIA. NVIDIA's rise wasn't planned as an AI conquest. It began with graphics, pixels, light, motion. The goal was realism in games and visual computing. But in chasing realism, NVIDIA accidentally built something far more powerful, a processor capable of performing thousands of calculations at the same time. When machine learning researchers discovered this, everything changed. Neural networks needed massive parallel computation, and GPUs were ready. NVIDIA leaned into this discovery, refining its hardware, improving performance, and building software that made scaling feel natural. As AI exploded, NVIDIA's vision became clear. Intelligence should be distributed, spread across thousands of processors, coordinated through fast networks, growing outward as demands increase. When one chip isn't enough, you add another, and another, and another. This strategy didn't just succeed, it defined modern AI. Entire industries were built on it. Without NVIDIA's approach, today's AI boom simply wouldn't exist. Cerebras looked at the same exploding AI workloads and saw something very different. Instead of asking how to connect more chips, it asked a more uncomfortable question. Why is intelligence fragmented in the first place? Their answer challenged decades of engineering instinct. Instead of breaking computation apart, Cerebras chose to bring it together, not onto a slightly larger chip, but onto an entire silicon wafer, transformed into a single processor. This wafer-scale engine doesn't treat intelligence as something to be distributed. It treats it as something that should live together in one continuous physical space. No long-distance communication, no stitching systems together, just one unified surface where every part of the model can interact instantly. Where NVIDIA scales outward, Cerebras scales inward. At the heart of this rivalry is a philosophical divide about how intelligence behaves. NVIDIA's approach assumes intelligence benefits from expansion, more units, more flexibility, more paths to scale. This mirrors how cloud computing grew: modular, adaptable, and resilient. Cerebras assumes the opposite. It argues that intelligence, especially at extreme scale, works best when it stays together, when communication is instant, when coordination isn't a problem to be solved, but a property of the system itself. Distributed systems are flexible and forgiving. You can add capacity gradually. You can reassign workloads, but they pay a constant tax in coordination. Unified systems remove that tax, but demand precision and specialization. Neither approach is right or wrong. They solve different problems. As AI models grow larger, communication becomes the hidden enemy. In NVIDIA's world, performance depends not just on how fast each chip is, but on how well thousands of chips can talk to each other. That conversation never stops. Every update, every adjustment, every learning step depends on data moving across machines. That movement costs time, energy, and complexity. Cerebras eliminates most of this cost by design. Data doesn't travel across buildings or networks. It flows directly across silicon. For large, tightly connected models, this creates a smoothness that feels almost unnatural, like thought without interruption. But this smoothness comes at a price. You lose the freedom to scale gradually. You gain unity, but sacrifice flexibility. NVIDIA's greatest advantage isn't just its chips, it's the world built around them. Developers, frameworks, libraries, and tools are deeply optimized for NVIDIA's approach. This makes entry easy. You can start small, grow big, and adapt continuously. Cerebras offers something different: architectural purity. It doesn't try to fit into existing assumptions. It asks developers to rethink how models are built, how data flows, and how learning happens when everything is local. The payoff can be enormous, but only if you are ready to commit. One strategy lowers the barrier to entry, the other raises the ceiling of what's possible. NVIDIA's approach serves breadth. It powers startups, enterprises, cloud providers, and researchers alike. It thrives in environments where adaptability matters more than perfection. Cerebras serves depth. It shines when problems are too large, too interconnected, or too inefficient for traditional clusters. It belongs in places where intelligence must act as one, not as a committee of machines. This is not a winner-takes-all battle. It's a division of labor. Cerebras and NVIDIA are not racing toward the same finish line. They are building different roads toward the future of intelligence. One builds cities of machines that think together. The other builds a single mind that thinks as one. The future of AI will need both: flexibility and unity, distribution and concentration, expansion and cohesion. The real story isn't which company wins. It's how these opposing philosophies together define the shape of thinking machines still to come.